we have four types of the units that we're going to derive. The first one is the length, and then we have mass, time, and temperature. The length with human measurements, that's from human units. We have meters, kilogram, seconds, and Kelvin. But for dimensional analysis, we can use capital L for length, capital M for mass, capital T for time, and theta for temperature. And we're going to use universal constant for our derivation. The first of the universal constant is h bar, which is reduced Planck constant, and that is h over 2 pi. Big G, which is the gravitational constant, which you can get from the Newton's gravitational law, which is the G, big M, little m, over r squared. Then the third one is speed of light in vacuum, and that is speed. And finally, the fourth constant is the Boltzmann constant, and that we can get that from PV equals N kb theta, theta being the temperature. The idea is to make the unit h bar equal to big G, which is equal to c, the speed of light, and that will be equal to kb, and all that will be equal to 1. Starting with h bar, which we know to be h over 2 pi, and that h is 6.6260715 times 10 to the power minus 34 joules seconds per radians, because that's in radians. And we can then write, so that's per cycle, and if we divide that by 2 pi, that'll be per radians. And we can write the value of that, if you divide it, that would be 1.0545171726 times 10 to the power minus 34 joules seconds per radians. So that's the units there. So we need to look at the units. So the unit for h bar will be joules seconds, and joules is force times distance, and then times the seconds. So this is joules, energy, force times distance times seconds. And the unit for force is newtons. Newtons is mass times acceleration, and mass is in kilogram. Acceleration is meters per second squared, so that will be s to the power minus 2, and then times that s, so that's times s, and that will be equal to kilogram meters per second. But that's newtons, but you need to times it by the distance, which is meters, times m, the distance, and that unit will then be kilogram meters squared per second. That's the unit of h bar. And we can write this unit using dimension analysis. So the h bar unit will be kilogram is mass, so that'll be capital M. Meter squared will be length squared. Time will be t to the power minus 1. And that's the unit we need to use for the h bar. For big G, we get that by rearranging the force, which is force times r squared over m1, m2, and that will be force times r over m1, m2. And force again is kilogram mass times acceleration, meters per second squared, then times meters, then times meters again, that meter and meter, over kilogram squared, and that can be written that we cancel one of those, so we get meter cube per second squared per kilogram. So that'll be units for big G. So big G unit will then be in length cube using dimension analysis, m to the power minus 1, and t, capital T to the power minus 2. So that's the units we need for big G, and that's the unit we need for h bar. For C, speed of light in vacuum, that is 299,792,458 meters per second, and that unit will be meters is length per second. For the Newton's gravitational constant, that value is 6.67384 times 10 to the power minus 11. Obviously, that will be meter cube per kilogram and per second squared. Finally, we need the kb unit, which we get from PV over Tn, but I need N. I don't need N because it's just the number of particles, so we're just using PV over T. But PV is energy over T, but energy is force times distance T. T being temperature in Kelvin, so that unit will be kilogram mass times acceleration, meter per second squared, then times meters again, which is that one, over Kelvin, and that can be written as in dimension analysis for KB, Boltzmann constant, and that value is 1.3806488 times 10 to the power minus 23 joules per Kelvin. So these are the 4 universal constant that we'll be using. Use these 4 universal constant will be to write them down again. H bar is L squared, M T to the power minus 1, G is L cubed, M to the power minus 1, T to the power minus 2, C is L T to the power minus 2, and KB is L squared, M T to the power minus 2, theta to the power minus 1. So that's what we are using. And how are we going to use it? We're going to represent L, M, and theta by stating that we're going to use them as H bar, C to the power alpha, times G to the power beta, times C to the power gamma, times Boltzmann constant to the power omega. So we're going to say that there's a power for these 4 values, which represent L. So if you look at a length, Planck length, we would expect Planck length to be written in terms of H bar alpha times G beta times C gamma times KB omega. Likewise, the mass, Planck mass, will be written same thing, H bar alpha times G beta times C gamma times KB omega. We have Planck time as well, H bar alpha. And finally, we have temperature, Planck temperature. So what we now need to do is to find alpha, beta, gamma, and omega for length, mass, time, and temperature. Alright, so to do that, what we now need to do is to write down the equation for that. So for length, when I look at length, that means all these will be 0 in terms of their power. So the power for length will be 1, and then the power for mass will be 0, time will be 0, theta will be 0. When I look for mass, Planck mass, the power will be 1, that will be 0, 0, 0. When I look for temperature, time, the power will be 1, that will be 0, 0, 0. When I look for temperature, the power will be 1, that will be 0, 0, 0. Okay, so let's put this together by incorporating this into there. These guys here, I'm going to translate that now. H bar is that, so I'm going to do H bar. That will be L, that's L squared, M T to the power minus 1, all to the power alpha. So that's what that is. I'm just replacing these here. And I'm going to put that here, put that there, put that there. And G will be L cube, M to the power minus 1, T to the power minus 2, and that will be beta. I'm going to do the same for C, which is L, T to the power minus 2, and that will be gamma. And finally, KB, which will be L squared, M, T to the power minus 2, theta minus 1, omega. What I could do is expand this out and collect all the like terms for L. So let's do that. So for L, alpha times 2, so that'll be 2 alpha, and L here, beta times 3. So we add them together, by the way, because same base, multiplying same base, you add the power. So that'll be plus 3 beta, gamma times 1 plus gamma, omega times 2 plus 2 omega. That's L. And then times M, alpha times 1, that's alpha. And then this will be beta times minus 1 minus beta. That will be, there's no gamma there, there's no gamma here, and omega will be plus omega. So that's M done. Now T, alpha, that's minus alpha, alpha times minus 1, beta times minus 2 beta, gamma minus 2 gamma, omega minus 2, isn't it? Minus 2 omega. And for theta, it's only one theta, so that's minus omega. So this is what I'm going to use. I'm going to equate for the length. I'll pick up the length to power 1 equal to L. Length to power 1 is equal to L, 2 alpha plus 3 beta plus gamma plus 2 omega. And for the m, well, because I'm looking at length, m will be 0 in terms of the power. So because I'm only considering the length, the rest will be 0. So that would be m 0, because length doesn't have mass. But I'm only working for length. So that would be m alpha minus beta plus omega. Also, I'm only looking for length. I'm not looking for, so the time will be 0 equal to t minus alpha minus 2 beta minus 2 gamma minus 2 omega, and again theta will be 0, and that is theta to minus omega. So for the length, which is what I'm just looking for, the length will be 1 equals to 2 alpha plus 3 beta plus gamma plus 2 omega. That's my equation 1. For m, because length doesn't have mass, so it's just going to be 0 equals to alpha minus beta plus omega. That's my equation 2. And time will be 0 equals to minus alpha minus 2 beta minus 2 gamma minus, I think that's just minus gamma, isn't it? Because time, that's just minus gamma. That's minus gamma. There's one gamma there for time, so that's minus gamma. Time is not, this is 1, so that will be yeah, so that's 1, because time is just length over time. Speed is length, distance traveled over time, so that's 1. So that's just 1 gamma minus 2 omega, that's 2 omega. And for theta, which is 0, will be equal to minus omega. So that's equation 3 and equation 4. Okay, now I need to solve these equations. Well, I know what omega is. Omega is 0. So that meant that omega is 0 for that one. And so this point here, we're find the Planck length. That's what we're finding there. That's why we chose that to be to power 1, because we're looking for that. The rest will be to power 0. When I'm finding mass, the rest will be to power 1. To power 0, and mass will be to power 1. So omega is 0 here, and therefore, and here I can put that 0 here, and I'll get 0 equals to alpha minus beta, which implies that alpha equals to beta. So I'm going to take that and that, I'm going to put it here, equation 1. So I'm going to get 1 equal to 2 alpha plus 3 alpha, because beta is alpha, plus gamma plus 0, because that's 0 times 2 is 0. And in this case, and then also I'm going to take these, I'll simplify these, and that'll be 1 equal to 5 alpha plus gamma. I'm going to take this and that, I'm going to put it here for that one as well. So I'm going to get 0 equals to minus alpha minus 2 alpha, because alpha is beta, minus gamma minus 0, because that's 0. And so I'll simplify this as well. Then 0 equal to minus 3 alpha minus gamma. That's equation, say, 5 and equation 6. I need to add these two together. That'll be equal to 1 plus 0 is 1, because it's a simultaneous equation, equal to 5 alpha minus 3 alpha is 2 alpha. Gamma minus gamma is 0, which implies that alpha equals to a half, and therefore beta equals to a half. If that's the case, I can find the gamma. If I come back to here or there, I can find gamma. So let's find gamma. The gamma will be, well, let's use this one. 0 minus equals to minus 3 alpha. Yes? And that'll be, take gamma to the other side, that'll be gamma. Gamma equals to minus 3 alpha, which is minus 3 over 2. Because alpha is a half, put a half there, that'll be 3 over 2. So gamma is minus 3 over 2. So we can write the length now, equation for length, back to here. Omega is 0, h bar is a half, beta is a half, and gamma is minus 3 over 2. So let's write that down. For length Planck, which is h bar alpha times g beta times c gamma times kb omega, and that is h bar a half, and c is minus 3 over 2, and kb is 0. So that means that disappeared. They both a half means root to power, so this will be h root times g root. This is to power minus, so that would be over, because minus means over. That would be c cube root. That's what that meant. And to put that together, so that would be root for everything. That would be h bar g over c cube. That's the Planck length. And that's what we got when we did the derivation using quantum and gravitational field approach. Classical and quantum, that's what we get. So yes, the Planck length from the universal constant gives us this value, and that's correct. Now we need to find the Planck mass. Okay, so we use the same thing that we did for Planck mass. So if I take this back in, that's what we use for, we're going to use that formula now. This will be 1. So we're going to use the same thing, this one, but this time this will be 1, that will be 0. So for Planck mass, we say M1 is equal to M alpha minus beta plus omega, and L0 will be equal to L2 alpha plus 3 beta plus gamma plus 2 omega, and for T0 will be T minus alpha minus 2 beta minus gamma minus 2 omega, and theta 0 will be theta minus omega. So what we want to do now is just use the powers now. So for 1 is equal to alpha minus beta plus omega. This one will be 0 equals to 2 alpha plus 3 beta plus gamma plus 2 omega for the length. And the t will be 0 equals to minus alpha minus 2 beta minus gamma minus 2 omega, and theta will be 0 equals to minus omega. Again, minus omega, that means omega equal to 0. Here we put 0 here, therefore 1 equals to alpha minus beta, which means I can make beta the subject, and that implies beta equals to alpha minus 1. So I'm going to put this and that into here. I'm going to put this and that into there. I would get, so 0 equals to 2 alpha, right? Plus 3 into bracket alpha minus 1, because I'm putting beta there, plus gamma plus 0, because omega is 0, and that will be equal to 2 alpha plus 3 alpha minus 3 plus gamma equal to 0. Minus 3 and minus 3 equal to 0. And I need to take minus 3 to the other side, and that will be 3 equals to 2 alpha plus 3 beta plus 3 alpha, plus gamma. But that is actually 5 alpha plus gamma and 3. Okay, so I'm going to take this and that, I'm going to put them into this one. So I got 0 equals to minus alpha minus 2 into bracket alpha minus 1 minus gamma minus 0, because that's 0, omega is 0. And we get 0 equals to minus alpha minus 2 alpha plus 2 minus gamma. Take the 2, well, let's just write it here. So what we can do is minus 2 equals to minus 3 alpha minus gamma. So we got equation 5 again, and equation 6. We need to add them together. I said it's a simultaneous equation. So 3 plus minus 2 is 1 equal to 5 minus 3 is 2 alpha, and therefore alpha equals a half. If alpha is a half, what is beta? Beta is a half minus 1, which is minus a half. So beta is minus a half, which meant if beta is minus a half, what is gamma? If I come back to this formula here or there, I know what gamma is. So gamma is going to be, let's put it here, gamma, I've got minus 2 equals to minus 3 alpha minus gamma. So if I take gamma to the other side, minus 2 to the other side, gamma equals to minus 3 alpha plus 2. Minus 3 alpha is a half, so minus 3 over 2 plus 2, which is 4 over 2, because I'll multiply 2 plus 2, 4 over 2 is plus 2, making them the same denominator, and that will give minus 3 plus 4 is 1 over 2, and gamma is a half. Okay, so now I need to put it into the formula for gamma. For the for mass, we know that mass is going to be h bar, or h bar alpha, g beta, c gamma, kb omega, and that will be h bar a half, g beta is minus a half, and c and gamma is a half, and kb is 0, which means I can write the formula for Planck mass will be, well, this is again, so that'll be root h bar, that'll be root c over, that's over by the way, over root g, and kb is 0. So what I've written down there, you might not see, will be that I've written the MP, let's write it here, mass is root h bar root c over root g. That's what this is, all right, which means it's going to be overall h bar c over g, and that's correct. Again, we've got Planck mass from dimension analysis. The next one is to get the Planck time from the dimension analysis. We bring this back again. This is the formula we're using. We're going to now find the Planck time, making this one 1. So we're making that 1, the rest will be 0, and then we plug in, we use this here. So for Planck time, and we're saying that the length, for length, will be 0. So that's the length. That'll be 0 and equal to 2 alpha plus 3 beta plus gamma plus 2 omega. For the mass, that will be 0 equal to alpha minus beta plus omega. For time, that would be 1 equals to minus alpha minus 2 beta minus gamma minus 2 omega. And finally, for temperature, that would be 0. Again, that is minus omega. Again, we need to solve this equation. So that's equation 1, equation 2, equation 3, equation 4. We need to find alpha, beta, gamma, and omega. This is 0, so I'm going to put it there. So I'm going to get 0 equals to alpha minus beta, because that's 0. And so that meant omega is 0, which implies that alpha is equal to beta. I'm going to take those two, I'm going to put them into the first one here, to get another equation. So that'll be 0 equals to 2 alpha plus 3 alpha, because that's 3 beta, beta is alpha, plus gamma plus 0, because omega is 0. So that I need to simplify. 0 equals to 5 alpha plus gamma, equation 5. I'm going to take this and that, I'm going to put it into this one. So that's 1 equal to minus alpha minus 2 alpha, because alpha is beta, minus gamma minus 0. And that would simplify to 1 equals to minus 3 alpha minus gamma. I need to add, this is equation 6. I need to add these two equations together, because this is minus, that's plus. So if we add them together, 0 plus 1 is 1. 5 alpha minus 3 alpha is 2 alpha. Gamma minus gamma is 0, which implies alpha is a half. Therefore, beta is 1 over 2. If beta is 1 over 2, alpha is 1 over 2, omega is 0, I can find gamma. So gamma will be equal to that one here, 5 alpha minus 5 alpha. Alpha is a half, so that gamma will be minus 5 over 2. So let's put this together for the time, because that's 1. For Planck times will be the h bar, h alpha is a half, g beta is a half, c gamma is minus 5 over 2, and kb omega is 0. And therefore, I could write Tp is root h bar times root g divided by root c to power 5, that's c to power 5, and to power minus a half, which means 1 over root, and kb is 0. Now put that together, that would be h bar g over c to power 5. So the Planck time is h bar g over c to power 5. And that's correct for Planck time. Now we need to find the Planck temperature. Find Planck temperature. And to find that, we have to write the length. Well, for length, that will be 0 because we're not looking for length. So that will be 2 alpha plus 3 beta plus gamma plus 2 omega. For mass, because we're not looking for mass, so that's 0. That will be alpha minus beta plus omega. For time, because we're not looking for time, that's 0 equal to minus alpha minus 2 beta minus gamma minus 2 omega. And finally, for temperature, we're looking for that will be 1 equals to minus omega, which implies that omega is minus 1. And if omega is minus 1, I need to put it here. If omega is minus 1, I put it there, so that'll be 0 equals to alpha minus beta minus 1, which implies that beta will be equal to alpha minus 1. So I'm going to put that and minus 1 into equation 1. This is equation 1, equation 2, equation 3, equation 4. So for equation 1, I get 0 equals to 2 alpha plus 3 into bracket alpha minus 1, because I replace beta with alpha minus 1, plus gamma minus 2 omega minus 2. I replace omega with minus 1, so that'll be minus 2. So omega is minus 1, that'll be minus 2. Minus, that's 2 times minus 1 is minus 2. And simplifying this, 0 equals to 2 alpha plus 3 alpha minus 3 plus gamma minus 2, that will be 0 equals to 5 alpha minus 5 plus gamma. Take the 5 to the other side. 5 equals to 5 alpha plus gamma. Equation 5. I'm going to put that and these into equation 3. So for equation 3, I get 0 equals to minus alpha minus 2 into bracket. Beta is alpha minus 1 and then minus gamma. Minus 2 times minus 1 is plus 2, because this is minus 1. Minus 2 times minus 1 is plus 2. Simplify this. 0 minus alpha minus 2 alpha plus 2 minus gamma plus 2. 0 equals to minus 3 alpha plus 4 minus gamma. Take the 4 to the other side. We get minus 4 equals to minus 3 gamma minus 3 alpha minus gamma. So what do we need to do? We got equation 6. I need to bring these two together. Yeah, I need to add them together. So minus 4 equals to minus 3 alpha minus gamma. Equation 6. Add together. 5 plus minus 4 is 1 equals to 5 alpha. That will be 2 alpha. That's 0. Therefore alpha equals a half. Alpha is a half. What is beta? Beta is a half minus 1, which is minus a half. Beta is minus a half. Alpha is a half. What is gamma when omega is 1? If I come back here or there, whichever one I choose, let's choose this one, equation 5. We know that 5 equals to 5 alpha plus gamma, which implies that gamma equals to 5 minus 5 alpha. We know what alpha is, so gamma will be 5 minus 5 over 2, because that's 1 times 5 times 1 divided by 2. I need to make these, which implies that gamma equals to 10 over 2 minus 5 over 2. This is 5 over 2 for gamma. In that case, I can write the temperature now, because that's 1. Temperature, Planck temperature, will be the alpha is a half, so that's h bar a half, beta is minus a half, g minus a half, gamma is 5 over 2, c 5 over 2. Right, for Planck temperature, we know that is going to be root h bar over root g, because that's minus a half, and this is root, well, that's a root c to power 5, right? Now this one here is going to be, because it's minus 1, so it's going to be root theta to minus 2, theta to power 2. Because if you get the minus 1, because if you root a square, you get 1. And that's that 1 there. The reason why it's in the denominator is because it's minus 1. So that, as I say, you could rewrite that as h a half g minus a half c to power 5 over 2, and then theta to minus 2 root, because that will give you minus 1. Because if you take the root, you get minus 1 back. So that's what we've done here. And bringing it together into all the square, so that'll be h bar c to power 5 over, well, that theta is actually kb, isn't it? So that should be kb. So that's a universal constant, is kb. So that is kb. This is kb. So that's h bar c to power 5 g kb squared. And that'll be the temperature. That's Planck temperature, because the power, this one is kb, not temperature, because it's universal constant. So again, that's correct, and that's what we need to derive. So we've done that using dimension analysis.